A few weeks ago I made a video with the question, can a LED be used as a sensor? Thanks to one of my followers, and I will give the link to the description, to the earlier video, etc, etc. Anyway, I was talking in that video that I wanted to do more experiments with infrared light. And well, I studied the whole issue a little bit and found on the World Wide Web that you can use a light emitting diode as a light sensor for visible light, perhaps also for other frequencies, invisible light, but you can also buy at Ali very cheap sensors. They are very cheap, you can see them here. I will tell more about them in the future. I ordered a few of them, and well, I also ordered a fierce ultraviolet light LED, and it must be so fierce that you even have here a heat sink, so it can get warm or even hot. The first thing was, of course, to say find a source, a LED, that could generate frequencies in the ultraviolet A and ultraviolet C range. And the UVC was, in my opinion, most interesting. And I found on AliExpress this unit. This is a LED that generates frequencies in the UVA and in the UVC band, C band. It's a dual LED band, and this is the part number. And here you can see the frequencies that it makes. For UVA 395 up to 400 nanometers, and UVC from 270 to 280 nanometers. The current is in both cases 40 milliampere, the current that the LED takes up. And the voltages are, of course, very, very important. Never exceed them. In that case, the LED will surely burn out. So the next adventure was to solder to this LED. This LED is approximately 4 millimeters. To solder wires to it, and you can see it here. It was successful, but it was a very big pain on the other hand. I've used this wire, copper twined, and I've used this soldering iron. You need a steady hand. Anyway, it was successful. So I have now connected the LEDs, both LEDs for UVA and UVC. And now the UVC LED is connected. So I want to show the whole setup first. And when I'm talking about A and C, I'm of course talking about the frequency bands. That's what I wanted to indicate here, frequencies. Well, always a problem. The datasheet on the World Wide Web on Ali did not give, in my opinion, exactly where the positive and the negative had to be connected. So this is the back side. I have by purpose not made here positive and negative indications, and I only want to focus on the front side. So when you have that LED at the front with the different LEDs here, this LED for UVA and this LED for UVC, there is a resistor here also, you can see it, with a loupe, a magnifying glass. So when you have that LED on the front, this is a positive, this is a negative, this is a positive, and this is a negative. This for UVC and this for UVA. And that is the situation here. We'll get as close as possible. On a certain moment my camera cannot focus any longer, but anyway, at the moment the UVC LED is active. So it strays out. I had expected that this radiation was not visible, but perhaps they have done that by purpose, because UVC radiation can be detrimental. Anyway, the current, the wattage that is strayed out by this UVC LED is tiny, only 1.123 milliwatts. So, but of course, say wear for safety, wear glasses. That's my idea, so that this frequency cannot damage your eyes. Though I think it's only 1 to 3 milliwatt anyway. Don't look directly, say, into a UVC source. But here I don't do that. So that was more or less all to tell. First thing was, of course, to find out where the positive and where the negative is. Well, and now I'm gonna use, now I know that the positive and the negative, so whether the LED is active or not, I will try to use these detectors. They are made for an Arduino, but of course they also send out an analog signal. That is of course logical. I don't know much about what kind of signal they stray out. They give out, not stray out, they give out perhaps a positive or negative voltage, perhaps another type of signal, but with the oscilloscope you can surely find out how this works. Perhaps interesting to show, voltage is now 5 volts. It's connected to the UVC LED that can handle maximum 6.5 volts. So perhaps it's interesting to show a little bit a somewhat higher voltage. Of course I don't want to burn the LED out. And now try to go to 6.5 volt. I have to be very careful. Now I'm on 6 volts. So I don't want to go higher, don't want to burn it out. So here there must be ultraviolet C radiation. And that's interesting. And of course I'm gonna try to test that, whether it is on the right frequency. I'm also gonna test different filters, different colors, say to block the ultraviolet C radiation. That will be in other experiments in the future. So thanks for watching. This was it all. And of course I'm going to try to use this LED. This is a LED that is sensitive for the UVA and UVC frequencies. I'm gonna try to use this as a sensor for especially UVC. Say the radiation that tans the skin, etc., etc. And furthermore, what I wanted to tell is that the frequency here is only a part of the UVC. So it's a narrow band. So when the sun shines, this frequency is present, but there are more frequencies that belong to the UVC band, etc. etc. When you want to know more, there's a lot of information on Google. Always funny to see such a LED working.